All right, so today we are going to be talking about trapezoids. So we've already covered parallelograms and the rectangle, rhombus, and square, which remember are all part of the parallelogram family. So all of those shapes have the two opposite sides that are parallel. We're now going to be talking about the trapezoid, who, on the other hand, only has one pair of parallel sides. So it will not be considered a parallelogram. So if we're looking at this trapezoid here, I'm going to label it A, B, C, and D, so we can talk about some of the pieces that are key to a trapezoid. So it's again going to have one pair of parallel sides, and these are known as their bases. So I'm going to highlight them in blue. Okay, so this BC and AD would be considered the bases because those are the two parallel sides that are there. So if I wanted to label those, I would of course use BC and AD. Remember, if we're talking about a segment, we put the line over top of the letters. And then they have one pair of non-parallel sides. And these are known as our legs. So I'm going to highlight those in green. Okay. And there are special times when those legs are going to be equal to one another, but they will not always be in the case of a trapezoid. So if I'm going to label those are AB and CD. Okay. So again, these are the legs. And I'm going to label it base 1, base 2. And if we're looking at the parallelogram, their consecutive angles will be supplementary. What this means is the consecutive angles that are formed by the parallel lines. So this angle here, which is right, will also be supplementary to that one that is vertically above it. Okay, and C and D would also be supplementary angles there, so they would add up to be 180 degrees. Again, these are the ones that are on opposite parallel lines. So notice that this one here was on base 1 and this one here was on base 2, which I forgot to label the 2. Okay, so that's how the consecutive angles there will work, and they'll be always supplementary. So let's look at a special trapezoid known as the isosceles trapezoid. It's still going to have its two parallel bases, which will be there at the top and the bottom here for this shape. So that's the base 1 and base 2. I'm going to label my shape again. Let's use C, D, E, and F. Okay, and the legs are also going to be those non-parallel sides. But what's special about these legs is that they are actually going to be congruent to one another. Okay, and remember, if they're congruent, it means that they're equal. So side CD is equal to side side FD. Okay, they'll actually be equal to one another. Their base angles will be congruent, just like the isosceles trapezoid. So this base angle here is going to be congruent to this one here. And that makes the top angles also congruent to one another because remember, they're supplementary to those that are the base angles. And always keep in mind that a quadrilateral does have a total of 360 degrees for its angles, okay? Then we have the vertical consecutive angles being supplementary, which we talked about last time. And then the diagonals here will actually also be congruent. So this diagonal here is going to equal this diagonal here, just like the rectangle. Okay, so their diagonals are going to be congruent. If we were to label that, that would say EC is equal to DF. We could also use the congruency symbols on both of those. Okay. And the last thing we're going to talk about with trapezoids is the median. Okay. And the median is that line that's in the middle, right? Median and middle. We use it when we're talking about averages and mode and all of that in statistics. But here the median is going to be the line that ends up being exactly in the middle of the trapezoid. And we're going to find that median there by taking and adding together our base 1 and our base 2 and dividing it by 2. Okay? Because again, we're taking that average, the middle. That's again if we're looking for the median. If we're looking for one of our two bases, the following formula is better to use if you're looking for a base. 2 times our median equals base 1 plus base 2. So depending on which piece you're looking for would determine which formula you would use. So again, this one was looking for the median. And the second one down there is looking for a base. Doesn't matter which base you're looking for, but you're looking for one of them. Okay. Again, if you have any questions about any of these things, please just write them down on the side of your notes and ask them in class when we go over these. Here, I'm just asking you to name the bases and the legs, and lastly, the median. This I will check in class, so please go through and to your best ability, name the median, the legs, and the bases, please. So I'm going to give you a few seconds here to go ahead and do that. All right, so if you struggled naming those pieces, we'll just talk about that in class, so please write a little question mark there so we can go over it. Example number 1, we're given a trapezoid that has bases the length of 37 and 19. So 37 is this top one and 19 is the bottom one. And we are asked what is the length of the median. So we have to recall our median formula, right? So we had the median equaled base 1 plus base 2 divided by 2. Okay, so I'm going to call it a big M, equals 37 plus 19 divided by 2. So 37 plus 19 gives us 56 divided by 2. And if we divide 56 by 2, we will get 28 as our median. And we can always double check that if we need to and make sure that 28 is indeed the middle between 37 and 19. Okay. In example number 2, we have a trapezoid where we're asked to find the length of the longer base. So this time we're asked to find the length of a base. So I'm going to use that 2 times my median equals base 1 plus base 2. Okay. When we know that the shorter one is 48 and the median is 56. So this is 48 and here's 56. So if I know my median is 56, it's going to be 2 times 56 equals, my base 1 is what I'm looking for. I'm just going to use B1 plus 48. And when we multiply 2 times 56, we're going to get 112 equals our B1 plus 48. Subtract the 48 to both sides, and our B1 will equal 64 there. Okay, again, you can always check to make sure it's the median. Make sure there's the same distance between 48 and 56 as 56 and 64. All right, now we're asked about some of their sides. So they tell us this is labeled home. So OM is 17x minus 13.5, and EH is 12x plus 14. Okay, we're asked to solve for x, OM, and EH. Now they tell us it's an isosceles trapezoid, which means those legs are going to be congruent. And remember, all we can do with sides is set them equal. So if they give you 2 legs, that all you got to do is set them equal because it's the only thing that you can do with these. So I'm going to set them equal to one another. I'm going to have 12x plus 14 equals 17x minus 13.5. Okay, I'm going to bring my 12x to the other side. I'm going to get 14 equals 5x minus 13.5. I'm going to add 13.5 to both sides. We get 27.5 equals 5x, or x equals 5.5. Now we've found x, so we've done this part of the problem. But we still need OM and EH. So if I take my 5.5 and I plug it back into both of these equations, so I'll have 12 times 5.5 plus 14. If I do that in math, I'm going to get 80. Okay, if I do it over here as well, I will also get 80. I did both just to double check that they were indeed the same. Okay. Again, if you're having any problems understanding, try to pause the video, go back, try it yourself, and then put a little question mark and we can work on it together. We have quadrilateral GHIJ is an isosceles trapezoid. So again, we know that those legs are going to be the same. We also know that their angles will be the same. I have labeled my wrong up here, so I'm going to fix it because they tell us that G is indeed congruent to H. So I'm going to switch H over here. J, I. Okay. So these two should be congruent to one another. So please make sure you label yours correctly when you draw it on there. Okay. They tell us that the measure of angle I is 65. And they want us to determine what the measure of angle G is. So one of our properties there that is that they consecutive angles are going to be supplementary. So I'm using consecutive angles. So those equal 180. So I'm going to take 180 equals 65 plus my x, because that's what I'm looking for. I'm looking for g. So if I subtract 65 from both sides, I will get 115 to equal my x. And if g is 115, h is also going to be 115 because it's that isosceles trapezoid. And then j, which is the base opposite our base angle, or consecutive to our base angle is what I should actually say. Opposite was not a good choice. Will be 65. So G, we had 115. H, we had 115 as well. And for J, we had 65. Okay. I would like you to please try example number 5 there on your own, and I'm going to check that in class, and we'll talk about it as well.